This is a railway. When it needs to cross a small river, a simple bridge is enough for the train to pass. But as the river widens, the bridge deck sags because the span is too long. So you build piers in the middle of the river to support the bridge deck. However, these piers block the passage of ships. You now need to design a large bridge that can span a wide river without obstructing navigation. You cleverly think, if I can't place piers in the middle, I'll move them to both sides instead. Let the bridge extend from the two banks toward the center, like two outstretched arms reaching for each other, or like two people stretching out their hands to hold each other. But when the span is too large, the middle of this bridge still shakes and bends, just like how your arms get tired if you keep them fully extended. So you shorten the free span of each arm, and add a steel plate in the middle, resting on the tips of the cantilevers, like two people slightly bending their arms inward to lift a plank together. This makes it easier to carry the load, but now the cantilevers themselves risk breaking under excessive bending moments. You then raise the height of the piers, and attach steel cables from the cantilever ends up to the pier tops, pulling them tight to increase their bending resistance. Yet when the load becomes too heavy, the bridge deck still bends, so you add diagonal braces beneath the bridge, channeling the forces downward into the piers. This combination of upward tension and downward compression significantly improves the stability of the bridge deck. However, in strong winds, the bridge still sways. You then decide to add triangular trusses into the cantilever structure. The inherent stability of triangles allows the forces to be distributed more evenly, preventing deformation caused by stress concentrated at a single point. But when a train reaches the middle, its enormous weight pulls the bridge inward, tilting it. To solve this, you anchor tie-downs at both ends of the bridge into the ground, pulling the entire structure tight and stable. Now, the river channel remains completely unobstructed, while the bridge easily carries trains and heavy vehicles. Congratulations, you have successfully invented the floating railway bridge.